This morning we're going to be doing rock properties in third grade. So each student needs your worksheet, your rock sample, your tool kit. That includes a nail, a hand lens, a pin and a magnet, and some tape and some scissors. Let's get started with this rock investigation today. And I'll tell you, I brought this rock along with me. This is a pretty big rock. And a rock, when you look at it, you can learn a lot about a rock by examining its properties. And properties are the things that we can see, feel, and measure about it. And so this rock, if you look up close, it has different minerals in it. I see some feldspar and quartz and mica and some maybe some quartzite. It has all these different minerals in it because it is a mixture. A rock is a mixture of different types of minerals. Let me show you what I mean. Okay, so here's our rock. And it's got all these different things in it. And so a rock is a mixture of minerals. Okay? It kind of reminds me of something I had for dinner last night, which was it was a salad, and the salad is a mixture of vegetables. And so just like a salad can have tomatoes and lettuce and cucumbers and onions and carrots in it, a rock can have calcite, and it can have quartz, and it can have iron and different minerals in it that make it up. So a rock is like a salad because a rock is a mixture of minerals. A salad is a mixture of vegetables. And so today we're going to look at some rocks. Each of you have your own specimen that we're going to examine. And take a look at your worksheet. Start by putting my name on it. You put yours on yours. And today's date. Now, there's a website here where I have 3 different shows that have to do with rocks and minerals. These are geology shows. Geology is the study of geo, the earth. And today you're going to be a geologist. That is a scientist that studies rocks and the earth. One show is called Earth Science. I have another show called Street Science, where we explore downtown and see how buildings are made with some pretty interesting minerals and rocks. And then we go deep underground to Underground Indiana. So these are some of the shows you can watch. And there's some new vocabulary. I'd like you to say these words with me. The first word is, well, rock. Mineral. Property. Property is something we can measure. We can see with our hand lens. We can measure with a ruler or a balance scale or a graduated cylinder, or I can feel it with our hands. A property has, for example, hardness is a property. Color is a property. Streak is a property. Magnetic, maybe a rock is magnetic. Crystal. Volume, how much space it takes up. Mass, how much stuff it has. And finally, I'm going to add one. Go ahead and add this word. Length, how long or wide something is. So these are the words that I expect you to be using today. Since you're a geologist, we're going to use tools and words and ideas like a geologist. Are you ready to get started? I am. First of all, I have my rock sample right here. You should have yours. Let's put it out on your worksheet. We're going to see if we can make some observations and write some notes about it, about your rock sample. It says my rock, and we're going to make a drawing of it. We're going to go through some of these properties. So the first thing I'd like you to do is just take your fingers and feel this rock. How does your rock feel? And teachers, you may want to help by putting some of these words on the board, like does it feel rough? Does it feel smooth? Does it feel greasy? Mine, and this is all these words we're using, is called texture. So mine is rough and bumpy. Mine is rough and bumpy. Okay? And so feel yours and make an observation. Okay, that's one observation. All right? Let's see. Oh, you know, mine is sparkling. Check this out. When I put it in the light just right, you can see sparkles here. And those sparkles, oh, there's even a big one right there in the middle. It's kind of black. See how it sparkles? Right there. That tells me that this has crystals. Now, crystals can come in different shapes and sizes. Here is rose quartz, and it has crystal. And here is a piece of pyrite, and this is how it came. It's got these squares on it. And here is copper, which is a mineral that has crystals and the way it kind of forms. Very interesting. And so we're looking at the crystal shape. And I even have this one right here, which is pretty amazing. And the crystals are so small, they actually come off. You can see those on my paper there. So I'm going to look at mine, and it has some crystal shape. I'm going to say yes. And I don't know what the shape is. They're just small. But I could use my hand lens to even look at them and see if I can see something even better. Okay, go ahead and examine, make observations about your rock sample. See if it has crystal shape. Go ahead. So we've talked about texture, crystal shape. Oh, look at that, magnetic. In your kit, you have a magnet. It may be stuck to the nail, like that one right there is. So I'm going to take a magnet, and some rocks a magnet will stick to. For example, here's a piece of iron. Magnets stick to iron. Let's see if that's true or not. Okay, here's my piece of iron. Here's my magnet. And look at that. It sticks right to it. Magnets stick to things that have iron in them. Look at that. So these two are magnetic. Now it's time for me to test mine. I put it on here, turn it sideways, and oh, mine is not magnetic. Not magnetic, magnetic. So I need to write magnetic, no. Test your rock to see if it's property of magnetism or if it's magnetic. Test it and then write your observation. Now this one is kind of easy, the color. I want to take a look at mine. I see some gray, I see some black and pink. So under color, I'm going to write mostly gray, black, and pink. Color is a property of a rock, and if we know the color, we're that much closer to knowing what type of rock it is. Check your color, make your observations. Now, in your kit, you're going to find a few other things. For example, there's a nail and a penny. All right, there's a nail and a penny. Now, a nail is very hard, and a penny is medium hard, and a fingernail is kind of soft. So we're going to use these three tools: your fingernail, a copper penny and a steel nail to see if we can understand another property, and that property is hardness, down here where it says hardness. So you have soft, medium, and hard. Now the way we're going to do this is that if my fingernail scratches it, it's going to be soft. If the penny scratches it, it's medium. If only the nail scratches it, it's hard. Hardness is a property of rocks and minerals. And if you know the hardness, you can learn a lot about identifying the mineral. Now I have a special kit here. It's called Minerals in the Scale of Hardness. And it talks about it has 10 different minerals because hardness scale is from 1 to 10. 1 being really soft like your fingernail and 10 being really hard. And so I brought with me a sample of 10 different minerals. 10 different minerals from softest to hardest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, talc is a mineral that's very soft. And this one here is called feldspar. That's a 6. Quartz is a 7. Beryl, corundum, and inside of this little container here is number 10. And it's very small because it's very valuable. And maybe you know what one of the hardest minerals is. See that little guy right there? Pretty small. It's right there. Let me show you. You know what it is? One of the hardest minerals in the world? I'll give you a hint. Girls love them. Guys like to buy them. This is a diamond. And a diamond, and that's a diamond right there, and that's a natural diamond. You can actually see the shape. It's very small. And a diamond is a 10. Is a 10 on the hardness. Now I'm going to put that back so I don't lose it. And so we have from a 1, 2, 3, 4, 5, 6, 7, 8, 9. The diamond is 10. So this diamond should be able to scratch any of the other minerals. So let's put this aside and see what our test is going to reveal. Okay, I'm going to start with my mineral and you start with yours. I'm going to start with my thumb. Well, that didn't work. It actually scratches my thumb. If I do that, look, you can see my thumb gets scratched by it. So this mineral is harder than my thumb. So I'm going to cross out soft. It's not soft. Okay? Test your thumb. Then I'm going to try a penny and see if I can scrape it with a penny. No, it's not scraping, and if I look, oh no, the penny is scraped. So you're telling me that this is, my mineral is harder than a penny. And you see those scratches it makes on it right there? Wow. So that means my mineral is not medium. If it's not hard, if it's not soft and it's not medium, it must be hard. Now the way I'm going to test that is if I'm going to see if this nail will scratch it, I'm going to come to the back here and, yep, look, I made some scratch marks right there in it. So I know that, can you see those scratch marks? So a nail is pretty hard. The nail is pretty hard. It's made of steel with some other elements mixed in to make it hard. So a nail is an alloy made from different minerals, iron, maybe some other materials to make it hard. And so this nail is hard. My mineral is hard. So I'm going to mark that property. Go ahead and test your mineral for hardness with your fingernail, with the penny, and with the steel nail. Well, we've talked about several properties: crystal, shape, the color of its magnetic, its hardness, its texture, how it feels. Now we're going to do one of the big ones that has to do with length and width, how long it is and how wide it is. In order to do that, we're going to make a science drawing. Okay, here we go. On your worksheet, there's a place that says Science Drawing Full Size. And so the best way for me to do a full-size rock is to actually trace it. So I'm going to look at my rock, I'm going to lay it down. You do the same thing, and then we're going to trace it. Trace yours, I'm going to trace mine. Anything that you see on it that you can trace or draw, we'll add that in later. So there's one here. And I might even turn my paper this way a little bit so I can do it a little bit better. Okay, there's the outline, and it's full size. But I need to add some more. This one kind of comes down all the way. I need to add more detail. To my rock. It has a piece of paper thing right here. It used to be like a little label. And now I'm going to see if I can get the same drawings in on it. Go ahead and draw your rock. And if you have any markers, that's very cool too. Oh, there's that crystal I was looking at right there. Nice crystal. Mine has crystals on it. Trying to make my rock look just like mine. That line there's a little rough. Okay. And since it's black and pink, I just happen to have a pink marker here. A lot of pink up here. Not too much down here. Okay, make your drawing full size. Now we're going to measure it, and we'll be using either a centimeter ruler or some centimeter cubes. But before we measure it, it's kind of hard to measure a rock that's all bumpy and not flat. So I have a technique that we can try. Now this one, something you may never have done before, so it might be just a little bit hard for you, but let's give it a shot anyway. Okay, check it out. Here's what we're going to do. We're going to make some guide lines. And the guide line, start at the top here and make it kind of light coming across. And I made it a parallel, so another line down here at the bottom. And so these two lines come out just about the same. See that right there? Okay, so I made two guidelines with my ruler because we're trying to find the length. This is the length we're going to do right here. So I'm going to put my ruler here, and I'm going to draw part of an arrow down and part of an arrow down. I'm going to put an arrow right here and right here. And this tells me the length. That's how long it is. We're looking up here at the length. So now all I need to do is measure that line. It makes it a lot easier than to measure on the rock. So here's some centimeter cubes. Let's see, there's 1 centimeter, 2, 3, 4 centimeters. So that's 4. I can confirm that with my ruler. 1, 2, 3, 4. So make out how easy it is to make this drawing and then to write in here 4 centimeters. Four centimeters, and that is the length. When I come over here, I'm going to go ahead and write 4 cm, which stands for centimeters. Okay? Once you do it that way, that's the length. Let's do the width. And so I'm going to come from this same point right here. Make a guide line down. I'm going to come to this corner right here and make a guide line down. So I got 2 guidelines for the length and 2 for the width, and these two come together. All I need to do now is draw an arrow. This might be hard for you to do, but give it a shot. Here's my arrow, and so now what this shows me is how wide is it? How wide is it? I can use my centimeter cubes again, and it looks like it's 1, 2, 3. I can confirm that with my ruler, centimeter ruler, and look at that right there. 1, 2, 3. So I need to write 3, for me, 3 centimeters. Centimeters. Now I'll be able to find my width, which is 3 centimeters. It's one of the properties of this particular rock, 3 cm. Go ahead and make your guidelines, make your measurements of how long your rock is and how wide your rock is in centimeters, which you can abbreviate as cm. I'll give you a chance to do that. Get started, geologist. All right, we've been using some tools that scientists use so far as we have taken our geology class here today. One of the tools we use that a geologist uses is a hand lens. And this hand lens helps you see things better. Another tool we use is a centimeter ruler that helps you measure things. And another tool we used were the centimeter cubes that we can also measure with. So we talked about measuring length and width and making observations. I have a couple more tools that scientists use that we're going to demonstrate right now. And one of them has to do with this. A cylinder, a graduate cylinder. It's a cylinder because of its shape, and it has marks on it, and that makes it a graduate cylinder, because this shows how much volume or how much space something takes up. And I have 3 of these. One is only 50 milliliters. One is twice as big, 100 milliliters. And this one, 250 milliliters. Let's use this tool to find the volume of our mineral. And so my rock is kind of big, so it won't fit in the 50, it won't fit in the 100, but it will fit in the 250. So here's my 250 milliliter. And if I move this a little bit closer, you can see that each one of these markings is about 5 milliliters. 5 milliliters. So I'm going to pour some water in so you can see it a little bit better. So I'm going to put some water in here. Move this a little bit closer so you can see it even better. So let me just fill it up to 150 milliliters. Tell me when to stop. Oh. 150 milliliters. So if I put my rock inside of here, is the level going to stay the same? Is the level going to go up? Or is the level going to go down? Make a prediction. As I put this rock in here, it's at 150 now. I'm going to draw that for you. Right now it's 150, so here's my graduate cylinder. Okay. And it goes up to 250 milliliters. And right now, I put liquid in at a 150 milliliters. Okay? So there's my liquid at 150 milliliters. You can see it right here. Okay? What's your prediction? When I put the rock in, is the water going to go up, stay the same, or go down? Let's find out. I'll move this back, put it in, and I'm going to slowly, I don't want it to splash, so I'm going to lower it slowly, and look what it did. It went up. Now it's at 160. There's 100 and, you can see there's 150, 155, 160. So by putting it in, that mineral takes up space, it displaced the water, it pushed the water up. And so now it's at 160 milliliters. So my question is, what is the volume of that rock? Is it 160, or is it the difference between where it started and where it went up? It's the difference. So we have to do a subtraction problem that looks like this. So here's our drawing now with this time it has okay, now this time it is up here at 160 milliliters. But it has the rock in it, so there's my rock in it. And it's gone up. And so the subtraction problem is, let's take what it is now, 160 milliliters, minus what it was, 150 milliliters. Anybody have an idea? The volume of my rock? 0 minus 0, 0. 6, take away 5 is 1. My rock is, in volume, 10 milliliter. 10 milliliters, or I can just say ml. 10 milliliters ml. Pretty cool. Pretty cool. Now I need to put the water back in here because I still want to do one more thing with my rock, and that is I want to find not how long it is, not how wide it is, but I want to find how much mass, how much it takes up. We know how much space it takes up, and so to find out how much mass it takes up, I need to use a different tool that scientists use. And you have 6 of these in your classroom. You have 6 graduated cylinders in your kit, and you have 6 balance scales to find the mass. So let's see how this works. This is another tool to find the mass. All right, so now, if I take this, here's my mineral. I'm going to put it on one of the pans. If I put it here, it goes down. If I put it here, it goes down. And so what I want to do is put it on this side. And now I'm going to see if I can find out how many of these cubes. What's so interesting about these cubes, they're 1 centimeter, but they're also 1 gram. So these are centimeter cube grams, which is kind of crazy, but I'm going to start adding them. Here's 1. Nope. 2 grams, 3 grams, 4 grams. There's 5 grams, 6, 7, 8, 9, 10, nothing. 11, 12, 13, 14, 15 grams, still nothing. 16, 17, 18, wait, I'm seeing some movement. 19, 20. My rock is more than 20 grams. 21, 22, 23, I'm seeing some movement here. 24, 25 grams, if I put one more. 26 grams. See the arrow right there? So my sample ended up being 26 grams. You can see right here is the sample, and right here are the 26 grams. Now I'll be able to know the mass of my sample, which is 26 grams. And the thing is, when I take it off, watch what happens. Ready? So my sample does take up space, and it does have mass, 26 grams. So I'm going to write that right here. 26 grams. Or I can just write 26 G for grams. So we've looked at some of the different aspects of properties of mineral. Now it's time for us to make a micro mineral slide, and you're going to need your worksheet to do this. I'm going to make 2 of these, and then I would like you just to sit back, make observations, watch how I do it, and then you're going to make your own with the materials that I've supplied you. All right? So here we go. Let's get started. You can finish up by writing some sentences about your mineral here, and I'm going to show you how to make a micro, which means small, mineral slide. And we're going to do it right here. There's 6 places. And for me, I'm going to show you how to do a salt slide and a pyrite slide. You don't need to write these down because you'll be doing your own slides here in just a moment. Okay, pretty simple. I'm going to take my worksheet, I'm going to turn it on its back, upside the back side, and I'm going to fold it back for those little diamonds that I had right here, the hardest mineral, remember those diamonds? And I'm going to try to fold it right on that, the middle of that. So, see how I did that? I'll show you again. There's this, turn it over, I'm going to fold it and crease it right here by those 2 diamonds, salt and pyrite. And I'm going to take my scissors, I'm going to make 1 cut here and 1 cut here, and it should just pop right out. If I did it, yep, there we go. So when I open it up, I have a hole there. Let me go ahead and do this one. Now teachers, if you had paper hole punches, those work also, but scissors work just fine. All right, so I've opened it up now, and I have 2 holes in my worksheet for my micro mineral slide. Salt and pyrite. Of course, it would fall right through right now if I tried it. So we're going to do one more thing. I'm going to turn it over, and there they are. I'm going to take some tape, and I'm going to put, let's do the salt one first. I'm just going to put a piece of tape over that, and I'm not trying not to push down. See how the tape's right in there? Can you see it? Try not to push down where the sticky part is. So I put a piece of tape on there. When I turn it over, you can see the tape is pretty sticky. It's right there. Now, I just happen to have some salt, and so I'm just going to put a little salt right here and push on it a little bit. Okay? And then I'm going to blow off, or actually it might be better just to shake it off onto the floor. Don't want to blow any of that in anybody's face. So I shook that off on the floor. But the cool thing was, look, some of it stuck right there. Now if I touch it, it's kind of bumpy, so I don't want it to be ruined. So what I'm going to do is take another piece of tape, and I'm going to put that tape right over it. And now my slide is complete. I can touch it, I can look at it, I can zoom in, I can backlight it. You can see some of the crystal shapes there. I can even use my hand lens to see if we can see some of the cubes. Check it out. Can you see that? Look at that. Look, you can see the squares in there. Salt has little cube crystals. I don't know if I can even try this guy right here. Look at that. Nice. So I've done one. This is my salt. I'm going to do one more with pyrite. We're going to do it the same way. Turn it over, put a piece of tape on the back. Try not to get your finger on it too much. There we go. Okay. Now, your teacher has several bags that look like this, and some of these might be empty. That's okay. We'll just share the ones we have. I do have more salt. If you have some empty bags, we can put salt in them. And don't walk around the room. The reason these are empty is because people have been spilling them, I think. I'm going to carefully remove this and set it right here. And here's my pyrite. And here's my minerals. Now, you don't want these large pieces. It's the small stuff we're interested in, okay? And so what I'm going to do is take this, push it down, and see how there's the sticky part? So I'm going to push it down like this. And look, some of the pieces stuck to this right here like that. And the last thing I need to do is take a piece of tape and put over it to keep my minerals there, and I can study these just like the salt, and I end up with 2 of my salt and pyrite micro minerals. So your job now is to use the materials I provided and make your own collection of micro minerals. I'll see you next time.